Hello, welcome to this talk with Terraform, Terraform data structures and algorithms. Before we go on, we should probably kind of define what that means. So the end goal of this really is, it's a new way of working with Terraform. It's less of technology, more of a change of method of working, which enables developers self-service. The goal really being to create a platform of reusable components where you can eventually shift left as much as possible, so that your developers, your end users, your less experienced people with infrastructure can start self-serving their needs with Terraform and doing it in a data structure approach. So you're not just copy and pasting the same resource block 50 times, you're actually defining things as data, where you can sort of regain one of the most fundamental benefits of Terraform, being the single source of truth. The amount of times I've seen sort of just a load of spaghetti that defines as Terraform, you quite quickly lose that single source of truth. If to try and understand it, you have to reverse engineer 10,000 lines of code, right? Suddenly your single source of truth doesn't ever materialize. Before we go on, I turned it off, there you go. Before we go on, you may have some questions now. Equally, you may go away, you may have a bit of a think, and then you may have some questions later, and you go, oh, I wish I thought of that. If you scan this QR code here, it will take you through to my website. That will have my email and LinkedIn, so feel free to pop me a question on there. Equally, there will be free demos at the end of this, which I'm hoping I'll have time for. But all of the code for those demos is publicly available on my GitHub, and that's also linked on my website there. So you can just go straight there, you can see all the demo code. Equally, if you, in like 2 weeks' time, go, oh, I wish I asked that question, you can get in touch with me and ask that question. So the actual content of this talk will be, I'm going to go over a bit of background around the particular conditions with which this paradigm and way of working sort of came to life. Some of the pain points and frustrations with a more traditional form of Terraform, which I'm sure you'll probably all recognise. And then some of the requirements which this paradigm tries to fulfil, and some of the benefits that can have. And that's something that I've seen realised at multiple clients as well. Actually, I didn't actually do my name, did I? That's awful. Hello, I'm Ben Clark. Well, you can call me Benjamin if I do something wrong, like, for example, forget to introduce myself. I'm a DevOps contractor, although I've been permy as well, for over a decade now at various firms, tending more on the larger side, your sort of multinationals and government organisations. Without further ado, again, questions. Not everyone in a room like this will be comfortable asking questions to the public. You may not want to raise your hand, in which case the folks organising this have put Slido here on this slightly blurry QR code, and you can use that in order to pose your questions, and we'll go through them at the end as well. Like I said though, equally, if you're not comfortable asking a question in a large format like this, you can get my email and LinkedIn. I'll also be hanging around afterwards, so you can come up to me and ask some questions then. So without further ado, let's have a bit of a situation going on, which is, there was a particular client of mine where when I came in, they were having this big project with hundreds of engineers across multiple organisations, and they were doing one feature release every 2 months. And the first thing that I do as a senior coming in going, what's your release cadence? Once every 2 months, I go, well, why? That's really slow, right? Back in, it was 2010, Flickr were going, oh, we're doing 10 releases a day, and you're doing one release every 2 months in 2014, that's a bit slow. And some of the pain points that we identified with that process, which this paradigm tries to fix, are ones that I'm sure you'll probably be familiar with. So in this particular instance, we had a monolithic code base. So if the word monolithic doesn't mean much to you, just all in one place. And that was also closely coupled. So in application development, you have the concept of coupling, where you have like 2 classes that are 2 coupled, you make changes in one, the other breaks. In this particular instance, you can see that a more traditional form of Terraform will quite often closely couple the app code and the infrastructure code. It becomes incredibly inflexible. It's hard to make changes in one or the other, and if you do make changes, it breaks, and that's not particularly great. Equally, you see a lot of times the individuals whom are your infrastructure experts are by necessity not application experts. The people who are your application experts aren't your infrastructure experts. And so your developers that are really, really, really good at developing aren't so great at doing cost-effective EC2s. Or your infrastructure engineers who are really, really, really good at infrastructure can't make a CRUD app in Python to save their life, right? And what that manifests in is that the infrastructure doesn't have value in and of itself, right? If you deploy an EC2 or an IGS, that's not valuable. What's valuable is once you've deployed that and you plug that into an application, whatever that is, and it starts getting in data or it starts executing business logic, that's where you have the value. And so you need that interplay of both your application and your infrastructure engineers. And a lot of the times that manifests in, you make a DevOps team and call it done, but you actually need to have the people work closely together in order to realize that. And a lot of times if you're having more traditional Terraform approaches, you'll find that the repo structures there for infrastructure first, so it's all built around how do we make the infrastructure as easy to deploy as possible. And that means your poor app developers sitting there going, oh, well, I want to write unit tests and I want to do linting. Can't, because the whole structure isn't set up to let them do that. And this is one you've probably seen a lot, the actual creation of the infrastructure in the more traditional setup can be very complicated. And actually instantiating that to fulfill your needs takes up all of your infrastructure people's time, and they have no time to do things like architecting or security or best practice, right? And it just becomes incredibly painful. And as an example of that, you may be familiar with a repo structure that kind of looks like this, right? Where you've got, for example, I don't know, 3 accounts, and you go, oh, I want parity in all these accounts. And you go, well, how am I going to do that? Well, you can't see, so I'm going to go there. How can you do that? And it's go, oh, we're going to put it all in one module and instantiate that everywhere. You end up having a behemoth like this that takes in 30 inputs and has 3,000 line policy.tf files with iron policies in there. You don't have a hope in hell of ever extending this or fixing it if it goes wrong, right? And when you sit down and you look at something like this, and you look at something like loads of teams trying to work together, in this particular instance of this particular client, we had to sit down and we thought, well, let's take a step back a bit. Like, what are our actual requirements? What do we want to do with Terraform, right? And I'm not going to go over all of this because it's obviously not all relevant for Terraform, but I want to put all of it here just to say that, yes, I'm going to show you a new way of working with Terraform. I'm going to show you a new paradigm. It works, it's been tested, it's great. But to see the best value from it, you quite often need to package that with a lot of other changes as well, like actually doing proper release engineering, like actually decoupling your code, actually giving your developers the ability to test that and deploy that and all that sort of stuff. And if you want to see the true benefits of it, you need to sort of do that whole collective package. But today we're just going to focus on what the Terraform code will look like in order to enable that self-service we spoke about earlier. And so let's try and take a think of what this approach looks like for both the developer and the user. And for the user, it looks like any other software, right? At the end of the day, Terraform is just code, and it should be treated as just code. And so you should be able to enforce a contract on it like any other software. You should be able to know what are my contextual dependencies, right? Do you know what I mean when I say something like the word contextual dependencies? I'm seeing nods, I'm seeing some shakes, I'm seeing some mixtures, okay? So let's say you have an EC2 instance that you're trying to deploy, right? And you as an organization are going to go, well, we don't want anything public, right? We want all of our EC2s on private subnets and we want to route them through a private VPC endpoint. That would be a contextual dependency. When you're deploying your Lambda, it's going to require the need to be on private subnet, for example. All those assumptions and standards and policies you have in an organization, they should be there up front. You shouldn't need to second guess them. You shouldn't need to roll out your app and then go, oh, we forgot to secure it and someone's managed to break in it. Like, that should all be as standard. Like, things like having a well-known interface. So if you import a package from an SDK, for example, or you install a CLI app or what have you, that will have a known interface for you to interact with it. You'll have a bunch of commands you have to use, you'll have a bunch of methods and classes, and they will have known interfaces. Similarly, your Terraform should have a known interface such that the user doesn't need to second guess how to use it. They just go, oh, this is my interface, these are my dependencies, let's go. And the crucial one to focus on here, because I'm not going to just read all of them, is this bottom one here, which is that our main requirement was that you shouldn't need to know Terraform to create or change infrastructure. That's just the medium by which you're making it. It's not the end goal in of itself. The end goal is to make infrastructure for a business use. So how do you create Terraform such that you don't even need to know the Terraform to work with it, right? What you should do is within the guardrails of the platform you've made is interact with data structures in order to mutate and change your Terraform, and that should have things like multiplicity and mutability and stuff such that once you set it up, you know, I'm sure we've all been there and say, oh, we need a Lambda. Great, okay, I've made you one. Oh, we need 5 more. I'll copy paste the resource block 5 times. Right, that quickly falls apart. So you should support things like multiplicity and mutability in your Terraform. Equally though, this is a great experience for the user, right, having all this, but what about the person actually building it? Right? So for them, they need a well-defined documented public interface, just like when you're making a class, a method, an app, or whatever, there should be a well-known interface, and I'll show you that in my demo, what that can look like. The data structure they use should be a collection. That, I'll move a bit. The data structure they're using should be a collection, so you can support things like multiplicity. That can take many forms. Often it's things like lists of maps or matrices, or it can be lists of lists or whatever. Right? If you think back to your third year of uni and you were doing data structures, you think, oh, a maps list is great. That sort of stuff, right? So you can actually support doing more than one of the thing. It should be mutable, and this is the big one, it should use a unified index. So what I mean by that is those of you who've been around a while and perhaps have even less hair than I do will remember Terraform 0.12 and before that, where the only way to do multiplicity was with counts. And so your indexes were 0, 1, 2, 3, and the second you got rid of something, all the indexes changed, all the infrastructure is destroyed, you have to recreate all of it from scratch, it was a nightmare. Right? Thankfully, since 0.12, they've introduced the ability to have indexing based on strings. And so that means if you use a unified index, you can make sure that under the hood, when you look at your state file, you're doing plans, you're doing applies, that you use an index that actually makes sense towards the thing you're doing. And if you change it, if you add something in your collection, you take something away, you don't want to force updating all of the rest of it, right? You just want to change the things you've actually changed. And equally, it should still be elegant, right? You should still have code that looks clean, you should still have code that looks good, you should still have code that you're not ashamed to show to the new hire or the grad or the intern, or when you leave the company, someone can't make heads or tails of it because it was only known to you and God and you've since left. Right? It should still be something that other people can actually interact with. And some of the results of taking all these concepts and thinking, oh great, I'm going to make this data structure Terraform, I'm going to apply algorithms, and by that I mean if all your infrastructure is just collections, then, oh, I want to deploy something different in dev to test, to prod. Well, that just becomes you applying some kind of algorithm to your data structure, right? You mutate it such that, oh, well, dev has this dictionary and prod has this dictionary, and pre-prod has both of them because great, awesome. Or you just change some attributes in there, and that's where the algorithm part comes in it, because if you distill all your infrastructure down into data structures and you want to change what you're deploying and how that behaves, that's just data structure operations. You don't need to do anything else other than change a string or add a dictionary or remove it or have an if statement or whatever, right? Far too often I see things copy pasted or over the shop going, well, if it's dev, you have a count of 0 and 1 and I have these 5 lambdas here and they live here, and it all just becomes spaghetti. Right? If you do all of this though, some of the results that I've seen is that your pull requests for infrastructure just become diffs and data structures. You're looking at your infrastructure and rather than going, oh, have they done this resource block right? Have they done this? What's this data source? You're just going, well, they've got a dictionary and the attributes look right, so sure, ship it. Or, oh, the attributes don't look right, sure, I'm not going to ship that. One thing that I saw in this particular engagement with a client was their release cadence was increased to 8 a day. I think our maximum was about 60 a week. Just because when you're developers who ultimately are writing the code that you're interested in that has the business value, when they can self-serve their needs, they can quite quickly and easily create infrastructure more than if they build all their code, give it to an ops guy, and the poor ops guy goes, well, I don't know how this works, what does this need? If you can give them the ability to actually define that themselves within guardrails, obviously, right? There's a reason that sysops is a thing. You don't want to have them get the biggest, chonkiest IGS instance ever and suddenly find yourself 50 grand in debt, right? So within the guardrails and within the platform you've built, they should be able to self-serve. And some of the benefits of that can be increasing release cadence. Equally, if you regain that single source of truth, right? If you regain the fact that Terraform does define your single source of truth, you look at one place and you go, this is all my infrastructure. One of the benefits that I've seen from that is your turnaround for actually identifying issues and fixing them is a lot quicker. In some cases, I've seen it be less than a minute. Right? You deploy something to prod, you go bam, you go, oh no, there's a problem, what is it? Oh, it's an IAM policy, well that's fine, it's just this dictionary, I'll put a new line in here, done, release it, fixed. Right? No drama, rather than you going, oh, I need to go look at this 3,000 line policy file now, where's the problem? You just have a single place, you fix it there. And yeah, fulfilling developer self-service and having a platform for usable components. I've contracted at multiple companies now, and every place I've been, this has been adopted as the gold standard for them, and they've seen benefits as a result of that. And I've spoken a lot about what it is, but I haven't actually shown you anything. So I've prepared 3 demos now for this. The first is we're going to look at what a module, and these are all AWS based, because that's my main sort of cloud that I interact with, but this is a paradigm, this is the way of working. It doesn't necessitate using AWS. You can do it with GCP, you can do it with Alibaba, you can do it with Azure, you can even do it with Vagrant if you really wanted to, right? So yeah, I'm going to show you one particular module that I've made, which is again publicly available on my GitHub. You can go and look at it in your own time, about what this might look like for a developer, and then 2 example repos showing solutions in their whole. So one will be a mono repo configuring a SaaS product. So in this instance, it will be GitHub. So having that single source of truth, right? If you're trying to manage, say, GitHub or not Bitbucket, because it doesn't have a provider, but GitLab or something, right? And you're trying to do that in Terraform, and you're doing that more traditional approach of loads and loads of resource blocks everywhere, and you go, oh God, how do I change it? I'll show you how you can do something with GitHub, and the fun fact I'd like to tell about that is one of the places I worked, my last ever pull request for them was me getting rid of myself from their GitHub, because it was just a single line of code. It was like, yeah, cool, I'm gone now, bye, merge, and then I lost access to everything. And then an example micro repo of how, if you've built a platform of reusable components, right? If you've got, for example, let's say AWS, and you're doing an ETL process, you've got Lambdas, S3 buckets, EventBridge, whatever, how you can utilize such a platform to put all those components together to fulfill a singular use case. And that's also available on my GitHub, and that use case will be an ETL process of just, if you're not familiar with that, extract, transform, load, of get some data, extract the data, figure out what the date time is, and then load it in another bucket with the date time and metadata. That's again all in code. So before I go on the demos, I've been talking, it seems, for 28 minutes. That's a lot of time. How is that for everyone? Questions, dramas, llamas, bananas? All good? Amazing. Let's have a look at some demos, shall we? And let's see them properly break. I should probably stand this. So let's look at our first demo here. Can you all see that in the back, by the way? Is that good? You can't see anything? That's not good.
I think it's Command Shift Plus.
This man knows his PyCharm shortcuts. He does not know his shortcuts.
No. Control Plus?
Pardon?
Control Plus? No. Command Plus. Yeah, it's Mac.
Ah. How about now at the back? Is that better? Hey, fantastic scenes. So, we can see here, and again, this is on my GitHub for you to see. Try not to turn my back to you, I'll go over here. You can see an example GitHub module here, which if you're not familiar with, is just a way for you to package a bunch of stuff together. Cool. And we can have a look at the main entry point for it. So if you remember, having that unified index and having that mutable data structure is important. Having that defined interface and contextual dependencies known is important. Otherwise, how your developer's going to know what they can make and what the guardrails are, right? And so the pattern I've adopted is to just document it. Just document it in your module here. And you can see here that if I, actually no, I want that, I'll just do that. There you go. You can see here that this just looks like any other bit of code you looked at in terms of what the requirements actually are, right? You've got the stuff that's required, you've got the stuff that's optional, you've got your constraints. Kushti, I know how to use the module, fantastic scenes. Under the hood, if we said before, we actually want some kind of collection, so we can do more than one with one thing even. You can use a list, is probably the most common example that I've seen, and then within that list using dictionaries, or I think Terraform calls them objects or maps or both, and within there mapping through attributes to various things. And so you can see an example data structure here where for each SNS topic we can define all the IAM policy statements in there. Equally, that's also a list, that's a nested list, so you can define more than one, right? So you can see here as well that there's no point in having constraints or data structures if you don't then validate what's in them, and so the benefit of doing something like this is you can put your own validation walls in there. This is coincidentally as well, I've only got some basic modules on my GitHub, and it's because when you're building a platform with reusable components like this, by necessity you're doing that for an organisation. They can have their own needs, their own constraints, their own business logics, and so I didn't see much value in trying to sort of do everything on there, because there's going to be someone out there that doesn't like it, doesn't quite fit the use case, but I think hopefully I've got enough examples on there to demonstrate the paradigm, the way of working to you, so you can take that back into your own organisations and then you can implement it yourselves there for your own business logic, your own constraints, your own needs. But yeah, you can do some validations, you can do regex for my sins. I actually quite like regex, you can judge me for that if you like. And all the various other bits and bobs. So that's our entry point, right? Some of you might be looking at that and going, well, that's great and all, but how do you translate that into something that's actually usable? And that's where the algorithm aspect of it also comes into play, because what is a usable data structure for an end user isn't necessarily the data in the format or the type you need to actually make the resources itself, right? That's just the interface the person interacts with. And so under the hood in your module, you can start to transform that, and we can start to see how that might look here. So in this example here, we just have a bunch of topics, just a really basic for each. That's something to keep you at home about. We can then see how this unified index and how we piece things together starts to come into play, and how we can start mutating those data structures. So if we look here, for example, we're allowing us to have an optional IAM policy list of dictionaries, and for that we're going to associate that with the corresponding SNS policy, because we're unifying the index by using the suffix there. That's something known to an individual item in our collection. And so provided we use that suffix across the hood and all our resources, we can link them all up and have them all cross-reference each other where they need to. And again, it's got some dynamics and whatnot. The actual policy itself is, once again, having this if in there. Let's just make that optional. It means that we don't have to define an SNS. We don't have to define IAM policies for an SNS topics. If you're doing like an email subscription, you don't need to give it an IAM policy to an RGS or a Lambda, right? So there's no reason to have that as something that's required. And yeah, the actual subscription itself, which just loops through and basically just binds everything together. And the Lambda permissions, which is something about those contextual dependencies. The stuff in your modules that you expose to the user are the things that have business value, right? If you go to user, oh, I want a Lambda. You're like, oh, okay, cool, I'll make you a Lambda. They shouldn't need to know that that Lambda needs access to EC2 NICs, for example, in its IAM to work, because they don't care about that. They care about what the Lambda needs for their business case, right? And so what you can do in these modules as well is under the hood, you can do all the plumbing so that all those things required by the platform, all those little itty-bitty things which the platform needs to function, you abstract that, you take that away, you deal with that in your module, such that the user can just focus on what they need and what has value to them. And in all these modules on my GitHub as well, there's an examples in there, so go and look at an example here. But I do have an actual end-to-end working demo as well, which I think over time, so I'll show you that as well. But you can see here that for the end user, all that they do is have a locals file here with a data structure. So you can see here how this might look for the end user, right? If you can all see that. They're just defining a dictionary in there of a notify me SNS topic that has both a Lambda subscription, which is this one, and an email subscription here. And we've got the IAM policy statements all here associated with an SNS topic, because you want to, as much as possible, but within reason obviously, bind together all the things your component needs to work. So if you're doing like a Lambda and EC2 and SNS, you probably want to include in your module the ability to define the IAM policies, the IAM roles in there, so it gets automated for the user. Because when it comes to you actually reading this and having it in operation, and let's remember code mostly is read, it's not mostly written, it's mostly out there in the wild doing things. If this breaks, you can come to it and go, well, it has this policy, it has this input, oh, I forgot to give it SNS publish, just whack it in there. Or, oh, I made a typo in the Lambda name, whack it in there. It's a lot easier to diagnose this when something breaks than it is to diagnose something like the massive mono repo that I showed you earlier with a 3,000 line policy file. Right? Questions on that before I move on to the mono repo example with GitHub? No. Evidently I'm extremely elegant. So, GitHub, we can see here, this is again on GitHub, funny enough, but I manage my own GitHub with GitHub, it's a bit recursive, and Terraform. And you can see here the way that that's done is I've got some logical mappings here, so I don't need to have these, but I've got a dictionary of dictionaries, and within those nested dictionaries I have more dictionaries, and that all defines all of my repos in one place. So that if I want to create another repo, I just come in here and I change that. Equally, if I want to change, say for example, the visibility of a repo, such as when I decided for SNS to be public all of yesterday, the PR for this will look very clean. So I'll just take this out real quick while I get on my GitHub, just to make sure I haven't got anything open that I shouldn't. And there we go. You can see now, you can see, for example, some of that PRs becoming diffs and data structures that I said earlier. Me making the SNS topic repo, the entire repo public, is that. It's a string. Right? If I want to change that back, I change that back to private, it's done. I'm not actually writing any Terraform to do this, I'm just mutating my data structure to be the state that I want. Right? The other benefit of this as well is that I'm defining all of my data structures natively in Terraform, because that's what I'm most familiar with. But Terraform doesn't have a templating language, so you could be defining this in JSON, or you could be defining it in any other thing, and then whacking that into the Terraform in order to work. And as long as you've got your validations and your documented interfaces, that's fine, right? This is a paradigm, it's a way of working. It's not a prescriptive, you have to do this. It's these are the principles, and this is how I've applied it, and you could potentially apply it other ways as well. But yeah, you can see here, I've got all my GitHub repos here. If we look at the actual module itself, this is one where we don't have a unified index, because what we're actually defining here is what we're actually defining is a singular instance of the thing we want, and then it's iterating over all of our stuff. Just because for a SaaS service, I tend to think that makes more sense, but again, you don't have to do it like that. You can see here it's iterating over all our dictionaries, creating repos. We've got some really cool defaults in here, so I've got like all my branch protections just there by default. I've got bootstrapped CI templates in here, I've got bootstrapped licenses, I've got code owner files, I've got bootstrapped readmes, git ignores, I've even got bootstrap templates. So whenever I create a repo, it does a regex on the name, and based on the type of repo it is, my CI template's there already. I don't need to do anything, right? It's just there for me, as is my pull request template. Because ultimately, if this was in an organization and I want to create, I've suddenly onboarded a new team and they need 100 repos, I don't want to have to manually make all of that. I want to define what the standard is, give them the toys, let them play in their prime, and then ship it out, and it all works. That's how you want. That's that, and that's quite a simple one. Now, I'm going to move on now to the modularized demo, unless there's any questions about that one. No? Cool, so this is probably my favourite one, because it's probably most close to the most useful application I've seen in the real world, which is having a bunch of these modules. How do I then utilise that to create an infrastructure in an account? How do I utilise that to fulfil a use case? So one thing I've actually glossed over is what I recommend is that each of these modules is its own Git repo. So like SNS is a repo, Lambda is a repo, blob storage, IGS, whatever. All of your components, each individual one is a repo with semantic versioning. If you're not familiar with that, that's major, minor, patch. You can signify if stuff breaks, stuff doesn't break, whatever. You have that all source controlled, you have that versioned, and then when it comes down to fulfilling a use case like this, you click on the right thing, and then you can see you just reference the version of the thing that you want, and you pass it in your data structure. So in this particular example here, we can see that my data structure is all documented. We expect that, that's great. But you can see I'm making an unzip lambda here. So if you take the time to read the README here, you'll discover two things about me. I like dogs, I like mythology. So this demo here has a bunch of raw data in it, with date times doing names of dogs that are spotted at locations, right? And the actual lambda itself takes a sip of all these files, it extracts the date time from the file name, it then extracts that from the raw layer into the process layer. If you're doing like a data lake operation, you tend to have a raw layer where all the data from your sources comes in, and then you do some stuff to it. You do the transform aspect of the ETL process, and then you load it into something else. So this is just literally going, I'm going to extract the date time, I'm going to whack that file somewhere else. And we've got our lambda here, you can see, it's nice and simple. We've got a source folder for lambda, we've got all our environment variables, we've got our IAM policies, and it all just looks nice and clean. We've got a bunch of recipe buckets here, and again, you can see it's nice and clean. We've got a login bucket, got a process bucket, got a lambda assets bucket. That looks sensible. We've got a bucket notification, such that if a zip file is uploaded to the dog's landing path in the raw bucket, it triggers the lambda. Again, if you were doing this in actual resource blocks, right, that's going to be like 50 lines of Terraform to try and figure out what that's doing. Seeing it in just a simple data structure like this, really, I just can't stress enough that single source of truth, that unlocks so much more potential in your estate. You can just see there what it's doing and how it's doing it. And then I've got a dummy SV file, which is just my config, with Terraform templating, because templating is great in Terraform. And that SNS module we saw earlier, got an actual use case of it, which is just creating a failure SNS, which emails my inquiries mailbox to go, oh, it's broke. Now, with all this in place, these are the modules, these are what they are, and then go, oh, that's great, we haven't actually instantiated it anywhere. So we've got an example account where we've got all these modules here. What I tend to recommend for these reusable components is they are functional components, they're not conceptual ones. So things like lambdas, buckets, stuff like that, as opposed to things like applications where it's like, oh, at A, at B, at C, whatever. The approach I tend to prefer is each application is its own repo. You have all the components needed for that application in that repo. You use this data structure to define what it looks like, you instantiate them in your account, job done. Then you've got clear separation of concerns, clear domains of interest, all that other good stuff that we want in an environment. And you can see here as well, having it separated like that means that we can ensure, for example, that the lambda creates after SNS by just basic Terraform dependencies, right? And that's one of the One of the failures of this is, like I said, it's a way of using Terraform. It's not a new technology, it's not a new language, right? If you go and use something like Terragrant, you're going to have to go learn a whole new way of working, you're going to have to learn a new technology, going to have to introduce new stuff into your tech stack, right? And I'm a big believer on KISS, right? Keep it simple because you're stupid, because I definitely am. So if you can do something with this much value with just native Terraform without introducing any other stuff into your tech stack, I think that's great because it's just quite simple. So without further ado, we can see what this actually deploys. So, did I log out on my? I did. Give me a sec. While I'm logging into my AWS, were there any questions about that? Yes, go for it.
Have you used, like you mentioned, like you could do it in JSON, for example. Have you used any other data formats or data structures to represent
I've only used JSON myself, but I think Terraform has quite a lot of templating languages where you can essentially take data structures and fire them at, because I'll let me load this up and I'll just show you. I'll show you what I mean. No, it's all good.
I've got something kind of along that lines of pull the JSON file out of an S3 bucket and you can do like JSON decode from into a local type of way, so you probably do that.
Yeah.
So
The only thing it's missing is like variables, really. That's just wondering if there's like another way to represent it that developers might be just as comfortable with.
Yeah, so I've seen my main audience has been like data engineers, and they've been quite comfortable just using the native Terraform because at the end of the day it's a matrix, it's just a list of dictionaries. But yeah, you can use JSON, you can serialize JSON, you can serialize other things. If I just quickly sign in, and I turn my phone off, which is great because it has two-factor authentication, that's amazing. Just trying to be polite during the other talk, and now it's biting me. Great.
In your last example, you've been referencing module using source from the same repository, from the same folder, essentially, just a few folders up.
Yeah, so the general, I'll plug it in now. It's
Yes.
just, it's
So
just,
generally, you prefer to use like HTTP reference to
yeah, so
the
it's,
repository location. Yeah.
yeah, so it's got two layers. The first layer is you've got a module locally that just wraps around the actual module that you care about, in which case it's this source control module here. And then you're referencing that in your account here, because it might be that, you know, under here you might have 3-4 accounts this application is deployed in. You may only want this in one of those accounts. You may want to change what versions of it get deployed in what accounts. But fundamentally, you need to have these reusable components decoupled from the application. Otherwise, you're not really getting a platform. Right? You're solving that problem for a single app, and that's great. But the second another application comes along with similar sort of interest and similar needs, you suddenly start doing things like symlinking, and that gets horrible. So I would have the two layers. There's the reusable module here, which is what you really care about. And then what I like to do locally is just have these individual modules here, just call that so that I can have really easy separation of concerns here. But you don't have to do that. But that's my particular flavour of it. Does that answer your question, sorry?
yeah, basically. I just see that there are different references actually for the source. Yeah, sometimes it's in the same repository, sometimes it's referencing completely different repository.
Yeah, so there's the, if I just do this, so there's two references, right? There's the modules here, which these essentially just wrap around our locals.tf. The only reason I've done this is because I basically wanted the ability to define the source folder a bit more easily. And so I've put this little wrap around it so that the source folder, if you look here, is just local to the repo. If I didn't do that, I would need to put something like that inside the actual data structure. And that is doable, that's fine, you can do that. I'm just a bit redundant and wanted it slightly cleaner, so I set up this more two-stage approach. But none of them are wrong. I will get you in a bit, does that answer your?
Yeah.
Okay, sorry, right, yes, sorry.
Yeah, I was just going back to what you said before about components and stuff like that for applications. So, would you recommend having Terraform stand up the application from within the application's GitHub repo, for example?
I would
Over having one big monorepos pushing out all your
Yes.
applications?
So I would absolutely, and it's what I went to, what I said earlier, right, about how you want your app engineers to have their best practices, you want the infra engineers to have their best practices. Because if you've got some poor Python guy trying to write a unit test, but he has to nest his things 6 folders deep to get that to work in a Lambda, he's not writing unit tests. What I would recommend doing is, and this depends on use case, right, but I like having the Terraform application code together. As you can see here, I've got my app code here. I've got my poetry, I've got my Lambda function, I've got my all my actual code here, but alongside my code I've also got all my Terraform. So I like to keep it as a self-contained unit, so that repo A corresponds to app A, and that's all you have to know about that app in order to deploy it. You can do a mono-repo approach. The danger with that is it becomes so unwieldy and so much going on that trying to make changes to it is hard, but using this paradigm, that sort of ceiling becomes a lot higher because everything's a lot more manageable. You could have a mono repo with 5, 6, 7 apps in it, and it would be more manageable if you didn't use this approach. But it's the whole mono micro repo debate, right? There's no particular right or wrong answer. It's more what's your use case, what's your context, what's your business. Like if I came up here and went, yes, every single time you use a micro repo, I won't be a good engineer because I won't take into account context. So, with that said, does that help?
Yeah. I mean, I've toyed with the idea myself before. I was wondering what the people.
Yeah. So the approach I've always done is keeping it is separating out repos per app, and then if you have shared components, having that in a separate one. So for example, if I've got project A, for example, and that's an ETL project, and I'll just use that because I seem to do lots of ETL these days, right? I'm processing data from data source A, data source B, data source C. Each of those will have their own repo. Within that repo will have all the app code in it, all the infrastructure needed to deploy that. And then I would also have like project A shared infrastructure or project A centralized infrastructure. And in there, I would have the centralized components they all share. So as much as possible, you want all these repos to be self-contained. If I want to redeploy app A, I don't want to have to also redeploy app B and C. I want to just do that one thing. And so what I'd recommend in that approach is you have all those apps as much as can be possible with their singular components that aren't closely coupled in one repo. All the stuff that's shared, have that in like a separate shared repo, and have as part of your workflow, as part of your deployment strategy. You go, well, I do the shared one first, and then that means the buckets are there, the database is there, the whatever's there, and then I deploy my apps on top of it that have the requirements for that. Does that make sense?
Yeah.
So in that case, does that mean you have different pipelines for the infra and the code?
Nope, just one pipeline.
Okay.
So you've got, so I'll just do this code before I get kicked out and have to go through this whole thing again, but I will answer your question, don't worry.
Different build steps, deployment steps.
Right, I can actually talk. Great. Sorry, could you repeat your question, please?
Yeah, I was asking, in that case, if you have multiple applications and multiple infra, separate repo, do you deploy multiple pipelines for that?
I prefer having one pipeline per repo. I like the explicit nature of going, this pipeline does this thing, this pipeline does this thing. If I want to, so that's why I said before that using this paradigm brings up a lot of questions, right? Because it's a really good way of working, but when you start to take a step back and think of the infrastructure as just another bit of data, you start to get to thinking, what's my release strategy? What's my deployment strategy? How do I roll that? How do I roll back? You start to think of all these more mature questions. One of those is, like you say, how do I deploy these things together? My preference is to have one deployment pipeline per repo, if that can be done, right? And so if we're taking that approach as earlier, where you've got the shared infrastructure, you've got all the different bits there, I would have separate pipelines for all of those, and then as part of my release engineering process, I would go, right, if I'm deploying this thing, as a release engineer, I'm going to write one book that's going to say, I do this, and then I do this, and then I do this, for example. Does that answer your question? Okay, cool. I think it's gone now actually. Yes, there was a question about the managed FTC. So we can see here the infrastructure that gets deployed. You can see we have our login bucket, our process bucket. Sorry, can you see at the back? Yeah, cool. We've got our login bucket, our process bucket, our raw bucket. If we're looking like a raw bucket, we've got our prefix in there. That's amazing. Look at our properties of the bucket, not the folder. We will see we've got version enabled, we've got encryption, we've got server access login, right? All that stuff is stuff you really want. And if you look here, we know we have that. That's the one. We know we have that because we have a really simple tree data structure that tells us that bucket has login and that bucket doesn't. We need to go and first engineer all that code. You can see it's actually gone and deployed that because we've just got a simple log bucket that's been provided to these ones and not to this one, right? So you can see we've got all these things here. If we look for lambdas, we can see we've actually deployed our lambda. Yeah. And it's got our SV trigger. That would be embarrassing if that didn't pop up. It's got the SV trigger. And if we look at the lambda permissions, it can be allowed to be executed from SV. All of that's been done with just that one simple data structure. You don't have to faff about trying to figure out how to actually do it. And if we actually run this demo live now, we can see in the process bucket, we've got nothing in our daily data. That's all full. We haven't seen any dogs. Not bad. If we go to our raw in here and we upload our zip of all the data, go to our process bucket, you can see it's extracted all of our files in there, it's encoded the date time, and it all works. All in a really simple, easy to read data structure. Right. Are there any Slido questions? Unless there's questions from the room as well. Just that's the demo, that's the talk. Hope you enjoyed it. Like I said, if you do have questions, come up and talk to me. Equally, my website, pseudoblart.com. If you go in there, it's got my email, it's got my LinkedIn. It's also got links to all the code demos. No.